Alrighty, welcome to the Openshift and Windows Drop 5 demo. So just to give an overview, this is a new implementation based on the concepts of operators. Literally, it's a lot more Kubernetes native implementation. It actually uses the Kubernetes node object to trigger the installation and joining of Windows nodes to the cluster. It uses the Red Hat CoreOS Ignition to drive the installation, and then all the components in this are Ignition files. They control the installation and setup of the Windows node. Then on the networking side, it uses OVN Networking, as well as the latest Kubernetes, matching the version on the Linux node for Openshift. In the demo environment, we're using ESXi from VMware 6.x. Of OpenShift, we're doing a bare metal install. This is straight from the OpenShift documentation using PXE boot, and then the web server supplying the ignition files and the Red Hat CoreOS images. We're using a 4.2 nightly build. The Windows image in this is a Windows Server 2019 with containers. Note that all 2019 server images will not work, and there must be some preliminary preparation done to enable Windows Remote Management Protocol, which is already done in the image we're using. So from the environment, everything is implemented in this in containers using Golang and static builds. This gives us a rapid install of the containers. And actually to add the Windows node, we actually use the worker ignition file, which is also used for adding Linux nodes to the cluster. And then the other thing we have is we need the kubelet config passed as well. So when we look at this, this is the install config YAML. We have 2 CoreOS-based workers and 3 masters. It's a pretty traditional install, and we do that install first. Now, in order for this to work, we need to use OVN networking. So if you notice the stanza a little bit towards the bottom of that, you'll see where we've actually commented out the traditional Red Hat SDN, and we've specified OVN. So this is a requirement for this to work. So then we go about creating the cluster. I have a standard clip script that literally goes out, powers off any existing test environment I have, clones each of the disks. For Red Hat CoreOS, we literally create empty disk because we're going to PXE boot those. In the Windows, we actually just clone the disk back from a template. We bring all of those back up. This takes about a few minutes only. And then we power on our VMs, and at that point we kick off the install. Now you'll notice here that we actually, when we run the installation, the OpenShift installer, it actually generates the ignition files, and we will copy those over to the web server. So then that the nodes will actually pull their ignition files from the web server. This is a standard part of bare metal install. All right, so this install continues. We're waiting for the install to complete. It goes up through 100%. The only thing we really do is we patch the registry to let it use a temp file, so we get a nice clean install. And the OpenShift is installed using OVN networking at this point. So now we need to pull down the installation script for the containers. That's stored in GitHub under WinOperator lifecycle, WinOp lifecycle. So we clone that down, go into that directory, and then we do the .install. This will set everything up automatically. There's basically a WinOperator component. There's a WinMachine manager, and then WinOperator data. There's currently 3 containers that are part of this. So the install script automatically runs through creating all of those. And then once we're done, we go back into the WinOperator project. As you can see, that's up. Now, there's parameters that are needed to be able to be set up, and we can do that by basically RSHing into the WinOperator container. It's a little CLI that lets us set the settings that we need. So we'll go through that in just a second. So those settings are global user. This is typically administrator, but could be others in your environment. It must be the admin user, but could be called different depending on what your internal policies are. The password that's used, global.password, means it's by default the password to log into administrator. We need the worker IGN, which comes from the Openshift installer. That must be base64 encoded, and you must get rid of the extraneous line feeds into that. So you can copy paste that. And then the kubeconfig data, again base64 with the line feeds cleaned up. And so you're just going to say set global.kubeconfig space and then that string. So once all of that is done, the WinOperator is ready to do the install. We need to basically create a node object. This is a Kubernetes node object. The important thing is we need to add in the host IP address, the node name, and the node name is expected to be the short name, not the FQDN, not the fully qualified domain name, but the short name. This has to do with how Windows handles naming in standalone nodes versus nodes joined to a domain. So we use the short name here and the IP address. So we basically create this file. This will be different depending on your environment. And then we kick off the install by telling Openshift the node is there. So we do an OC create, giving it the node file, which kicks us off. So at that point, we're going to switch over to the Windows node. So I have remote desktop in to the Windows node. When what you see now, the first thing it'll actually, under program files, create a WindowsNodeManager object. This is done by the machine manager automatically, if it can log into the machine. And it will then copy down the WindowsNodeManager automatically. The Windows Machine Manager does the full lifecycle management for the Node Manager. When the Node Manager then starts as a Windows service, it creates the additional directories you see here, the content, the logs, and such. So at that point, the install is running. We get a log file, which is under that logs directory you saw. And then you see it will start. It first downloads a template file that tells it what content is needed. These are the components of the install. You can see these are all done as ignition files. These are part of WinOperator data, which is actually running as a container within Openshift, or optionally can be part of Windows Machine Manager. So just to give you kind of a quick overview here, we have the prerequisites module, which basically handles the updates, installation of the basic components needed for this to run, Docker, which is pretty obvious when you're doing containers. The pause container, which is the principal namespace shared across all containers, that's a required part. NSSM is the open source service manager that lets us run kubelet and OVN as Windows services. OC is the Openshift command line tool. Node actually handles the addition of the node to the cluster. CNI is part of the Kubernetes networking stack. And then you have OVS, which is the Open vSwitch. SDN, which is a software-defined networking, which basically bridges between OVS and OVN. And then finally OVN and then Kubernetes. So when you see using it, it's basically taking the ignition file, deploying all the assets with those. Those assets can be part of the ignition file or downloaded from the web as specified by ignition. And then it will use the metadata to start executing commands. So you'll see the pre-win is executing off the bat. This is doing all our installs. As part of that install, what will happen is the installation will run, and then to install the updates, a reboot will occur. So at that point, the Windows Node Manager restarts. It will notice that restart and continue the deployment. This is built into Windows Node Manager, and nothing has to be done in the components to handle that. In the install, there's only really one reboot needed. After the reboot, we pause for a moment to let everything settle for all the updates to install and such before we continue. So the next off, the Docker component is installed. This is a scripted manual install to make it really reliable. that runs, setting up Docker and getting everything we need for Docker to work properly. At that point, then we need to pull the pause container. The pause container is a pre-built Microsoft image that has some specific parameters in this version of Kubernetes to enable the networking to work properly. So that is pulled down. At that point, then we get the node added. This is the node module that you'll see run. That basically pulls uses a worker ignition file, pulls all your larger set of ignition files with all the certificates and everything needed. That's pulled down. Effectively, at that point, we have everything we need to add the node as far as certificates and setup. We still need to set up the CNI and then the software-defined networking layers. The software-defined networking actually sets up the virtual switches and sets up all the networking components in preparation for the OVN component. So you see the OVS kicking off here, and then finally the kubeOVN is kicking off. So we install the kubeOVN service, which is started as a Windows service, and then finally Kubernetes. So if you look at the time log, this usually takes 15 to 20 minutes up to this point to go through. So you can see the completion of that. We actually use the OC tool. Notice we're still on Windows here. With this, the node is actually added. You can actually see the added node there. And then at this point, we're ready for a demo of running a Windows container. So we actually use we use WinPacman, which is sitting in my GitHub. You can see the URL there. This is a Windows Node.js app. Just to give you an idea, this is the Dockerfile used to create that. This has to be run obviously on a Windows node, and the container created, if you look at the build script that's in there, it will take this and then push it up to Docker Hub. So let's run this. We use the deploy script, the deploy 2019 script. We'll pull down a YAML file that defines it and create it. And then you can see we have a pod. At this point, it's creating. Now, creating, basically, everything is set up, but we have to download the base Windows image, which is quite lengthy. In our case, we have to pull that from Microsoft, and it takes a while. Now, obviously, in your organization, you would typically have a registry, and you could pull that locally, which would make that incredibly fast. Just to show you, we do have a pod. You notice it has its own IP address. This is software-defined networking at work. So OVN is assigned this pod a 10.129.2.3 address automatically. You'll notice the node is WinNode1, so this is running on Windows. And then we assigned it to the node. This is on the describe, and you see it start pulling the image. Now, mind you, because this is a full-size window image, it takes some significant time. The total download for this is about 5 gig, so it will not be fast. Depending on your implementation, your network, and other variables, this could take an hour. Just to show you that it's happening in the background, this is the kubelet log sitting on the Windows machine. You can see it running. And it's still running. You can see the passage of time. I wouldn't make you sit through 20 to 30 minutes watching the little bar run, but it takes some time. And then finally, after all of that is done, we succeeded in pulling the image. Roughly an hour later, you see the container is successfully created and started. So intervening time, roughly an hour. At this point, when you start looking at it, okay, that's all of that. Extraneous slide. And then let's go and look at the Windows console. So here, this is the OpenShift console. So everything is running normally. We go into our projects. You will see that when Pacman is running, so everything is up and running. You see the routes. This is working properly. And Pacman is running nicely. So this is a Node.js application running from Windows. So in order for this to work, everything has to be able to be routed properly. So the networking is working here. Everything is in good shape. So that's it. That is it working. So if there's any questions, feel free. You can contact me at gwest@redhat.com. That is the completion of the demo for Dockerfile.